High-pressure die casting versus vacuum-assisted high-pressure die casting by Dale Miller. This will be a quick, technical briefing on the capabilities, advantages, and limitations of two manufacturing processes, with one being a conventional manufacturing process and one being an advanced manufacturing process. The conventional manufacturing process for the production of easier parts is high-pressure die casting. The advanced manufacturing process for the production of more complex parts is vacuum-assisted high-pressure die casting. This technical briefing assumes that you already have basic knowledge of both of these processes and will not be explained in detail during this briefing. This briefing will then discuss the manufacturing readiness level of each of these processes in order to accurately represent the manufacturing maturity of the processes and where a company would stand attempting to integrate them into our production line. Advantages of basic high-pressure die casting. Starting off, the capabilities and advantages of basic high-pressure die casting include castings with a high casting yield, up to 95%, high to very high near net shape, high levels of surface finish, and high dimensional control. All of these factors minimize the amount of machining and finishing that must be done after the casting is completed and increases manufacturability in terms of cost. Depending on the size and geometry of the component, multiple cavity dies can be created. This allows for the production of multiple parts within each individual process cycle. There is no sand or binder cost or issues in high-pressure die casting. The rapid injection and cooling rates will end up yielding a very refined microstructure with improved levels of mechanical properties. Better control of the solidification of the molten metal than other manufacturing processes with the use of internal cooling passages within the die. This will also enhance the microstructure, which allows for more optimized properties to be obtained in specific locations within the casting. And this type of casting works well with alloys of aluminum, copper, magnesium, zinc, lead, and tin because they are all non-ferrous metals with low melting points. The disadvantages of basic high-pressure die casting. The limitations of basic high-pressure die casting include a die needs to have the ability to open and close along a specific dimension, or what's known as the parting line. This means that the desired product cannot be made with complex internal geometries. While this is a very serious and major shape limitation for some components, such as engine blocks and cylinder heads, this is less of an issue for structural components due to them having simple three-dimensional geometries. The upfront costs associated with high-pressure die casting are high. Metal dies and tooling are required along with the necessary hydraulics and a die casting machine. More often than not, this process will not be easily scalable. The high-pressure die casting machines have a finite capacity for production. If the production requirements exceed this capacity, another machine must be purchased along with the dies and tooling, which increases the cost substantially. The high injection velocities often trap air in the casting, allowing porosity to arise in the product. Additionally, the rapid cooling rates can concentrate porosity and inclusions along the center line of a casting. Both of these factors can reduce the mechanical properties of the casting. The presence of air that gets trapped inside the casting also often prevents these castings from being heat-treated in order to attempt to negate the reduction of mechanical properties. The maximum strength properties obtainable are often much lower in high-pressure die casting components compared with other permanent mold and sandcast processes. The non-uniformity of properties tends to increase as the size and/or thickness of the high-pressure die casting component increases. This type of casting will struggle with alloys of iron because of the high melting points that will cause imperfections while the cast is being injected. Advantages of vacuum-assisted high-pressure die casting. The vacuum-assisted high-pressure die casting advantages include, as mentioned previously, the high injection velocities often trap air in the casting, allowing porosity to arise in the product for basic high-pressure die casting. While the air is being sucked out with the vacuum, the mechanical properties of the high-pressure die casting are not lowered. The result is a high-integrity part with very low levels of porosity and high mechanical properties. This version of the casting process is used to produce critical components using light alloys, such as structural and safety components for motor vehicles. And prototyping with vacuum-assisted high-pressure die casting is fairly quick and yields immediate results. Disadvantages of vacuum-assisted high-pressure die casting. The vacuum-assisted high-pressure die casting disadvantages include: even though the prototyping is quick, it is not recommended as there is a high initial cost associated with production. Especially when trying to prototype a new product, it is not advised to immediately start with the vacuum-assisted high-pressure die casting unless the product that is attempting to be made cannot be made through regular die casting. Despite the hype of the quality parts made using vacuum-assisted high-pressure die casting, the trade-offs for high integrity in a part will only be worth the cost once the manufacturing process is set in place, and it will be harder to convert existing die casting machines and equipment into vacuum-assisted high-pressure die casting machines and equipment. If the product has thin sections, the shrinkage rate is higher, and the chance for a part to be warped during the casting process is higher than basic high-pressure die casting. The air that is removed for the sake of decreasing the porosity also helps to negate the shrinkage. When looking at the manufacturing readiness levels, it is important to start from the lowest level and explain why each stage can be passed with a given manufacturing process. The first 4 levels are easily passed by both basic high-pressure die casting and vacuum-assisted. The basic needs to manufacture these processes has been identified and can be located with the correct investment. There are many materials that these processes can use in order to form a product, and proof of concept is easily achievable. Lastly, the key design parameters have been identified and the limitations going forward have been noted. Moving on to the middle section, the processes begin to differ. As mentioned previously, the prototype costs will be much higher with the vacuum-assisted high-pressure die castings. This will serve as a tough bar to overcome for smaller companies that cannot afford it and will seek slower but cheaper options that are more realistic. However, basic high-pressure die casting can move farther up the manufacturing readiness levels for both large and small companies by having a lower bar to entry and transitioning into easy-to-work-out processes. In the general industry, many high-pressure die castings will make it to level 8, given how many materials can be used and easy-to-define costs are included. While the cost for basic high-pressure die casting may be high, the investment can usually be justified. Lastly, the higher levels show the greatest differences between basic high-pressure die casting and vacuum-assisted. For large companies, it is easy to see how systems can be put in place to take advantage of the benefits of vacuum-assisted. Money spent speeding up the process and designing detailed systems is returned by increasing the rate of production based on the prototype system and expanding the system as time goes on. For smaller companies, this type of expansion, with having to keep a close monitor on quality, is not as necessary, as they will be producing few parts. Smaller companies will also not need to intervene as much on the reliability of the machines they use because of how low the production risks are. Based on the ideas, I have rated basic high-pressure die casting at a manufacturing readiness level of 8 for small companies and a 10 for large companies. This process is fairly simple and can be taken advantage of at any level in order to create a product. For vacuum-assisted high-pressure die casting, the rate is lower at 4 for smaller companies and 9 for larger companies. In most cases, the vacuum-assisted process would be preferred for its numerous advantages over basic high-pressure die casting. However, because of the higher initial costs and the higher rate of shrinkage, basic high-pressure die casting is more reasonable to bring to a large-scale production than vacuum-assisted. Lastly, the sources I used for this briefing contain mainly books based on the science and production capabilities of different processes. Some of the books have a specific product in mind, such as motor vehicles, and other general vacuum-assisted high-pressure die casting technology. With this bias in mind, I tried my best to look at advantages and disadvantages of each process. Thank you for your time, and please try to keep these differences in mind as we continue to develop and improve processes at our company.